Hello! In this video, we're going to look at some more complex molecules and how to draw their Lewis diagrams. So one thing that's going to be really handy moving forward is figuring out the number of bonds that an atom can form. And this can be predicted from the number of electrons that they need to reach an octet, or 8 valence electrons. So let's look at carbon first. So carbon is in group 4, so it has 4 valence electrons. So its Lewis diagram has 1 electron on each side of the symbol for carbon. Now we know that it wants 4 more electrons to have a total of 8. So that means that carbon can form 4 bonds. So that is shown in our table down below. Now let's look at nitrogen next. So nitrogen is in group 5. So it has 5 valence electrons. And that means it wants 3 more electrons to have a total of 8. So it can make 3 bonds. The other way that you can think about it is how many unpaired electrons does each atom have? So carbon has 4 unpaired electrons, which means it can make 4 bonds, where it pairs those electrons up with other atoms. Nitrogen has 3 unpaired electrons, so it could pair those up with 3 other atoms and make 3 bonds. So let's look at oxygen. Oxygen has 6 valence electrons because it's in group 6. So if we look at its Lewis diagram, oxygen has 2 unpaired electrons, so it could make 2 bonds with those unpaired electrons. And we saw previously with fluorine that fluorine has 1 unpaired electron, right? So I'll just draw that right here. It has 7 valence electrons, and one of those electrons is unpaired. So it could make a bond with that unpaired electron. And then in the last column of this table, we can see the number of lone pairs. So carbon doesn't have any pairs of electrons, or lone pairs, right? We also called those non-bonding pairs of electrons. Nitrogen does have 1 lone pair of electrons. Oxygen has 2, and fluorine has 3. So we can see that down below in the last column of the table too. So now that we can see how many bonds each atom can make, or how many covalent bonds they can make, we can now start to predict what molecules will look like. So let's look at water. Let's draw the Lewis diagram for water, which is H2O. Now the first thing we need to do is figure out which atom is going to be in the middle of the molecule. So what's going to be our central atom? And I have a tip here for figuring that out. It's usually the atom that is by itself, so there's only one of them, or the atom that can make the most bonds. So if we compare hydrogen to oxygen, we know hydrogen is in group 1 of the periodic table, so it has 1 valence electron, and that means it can only make 1 bond. We just saw that oxygen is in group 6 of the periodic table, so it has 6 valence electrons, and it has 2 unpaired electrons, so it can make 2 bonds. So that tells us that oxygen is going to be in the middle of this molecule. It is by itself in the molecular formula. There's only 1 oxygen, and it can make the most bonds out of all of the atoms in the molecule. So now that we know oxygen is going to be in the middle, let's draw the Lewis diagram for that. And I tend to put the unpaired electrons near each other rather than opposite each other. We'll talk about that later, but typically lone pairs of electrons like to be closer to each other, so I tend to put them kind of near each other. But we'll get into that when we start talking about shapes of molecules later on. Anyway, so we have our two unpaired electrons for oxygen, and we have two hydrogen atoms, each with one unpaired electron. So now we can start to see our covalent bonds forming. Now remember, we can also draw those covalent bonds as lines. So we could draw a line for each bond to hydrogen. So that is the Lewis diagram for water. So not too bad. Let's try a couple more molecules that have multiple atoms. So let's try drawing the Lewis diagrams for CH4 and NCl3. So remember, try to figure out which atom goes in the middle, and then you can put the other atoms around that central atom and start pairing up any unpaired electrons. So I'll let you try this on your own first. You can pause the video while you do that. And when you're done, you can unpause and we'll go over it together. Okay, let's start with CH4. So it looks like carbon is by itself. There's only one carbon. So I'm going to assume it's in the middle, but some more evidence for that is carbon, remember, has 4 valence electrons, so it can make 4 bonds. But we just saw on the last slide that hydrogen can only make 1 bond. So that gives us a lot of evidence that carbon is in the middle of the molecule. So now we can surround the carbon with our 4 hydrogen atoms, and each one has 1 unpaired electron. So that's going to work out perfectly because now we have 4 covalent bonds that are forming. Now, for these molecules, I've been drawing the electrons side by side rather than kind of squished in the middle of the 2 atoms. That's totally fine. You can draw it that way. I don't mind. But remember, we could also draw each of those covalent bonds as lines. So that is our Lewis diagram for CH4. So now let's look at NCl3. Again, nitrogen is on its own. There's only 1 nitrogen, so that's likely going to be in the middle. But additionally, if we look at the Lewis diagrams for each atom, nitrogen has 5 valence electrons, and we just saw that it can make 3 bonds. And then each chlorine has 7 valence electrons, and it only has 1 unpaired electron, so chlorine can only make 1 bond. So that gives us a lot of evidence for nitrogen to be the central atom. Okay, so let's draw nitrogen in the middle, and then we'll put our chlorine atoms around nitrogen, and we'll make sure that we're pairing up the unpaired electron for each chlorine. All right, so we've got our 3 covalent bonds between nitrogen and each chlorine. So we can redraw those as lines. And then we just have to include those lone pairs or non-bonding pairs of electrons for each atom. So who knew chemistry had some art in it? We're drawing more than we're doing anything else at this point. Okay, so that's our Lewis diagram for NCl3. Now, sometimes molecules can actually form more than a single bond between atoms, because so far we've just been showing one bond between two atoms. But you can actually have some situations where you need two bonds between atoms, or even three bonds. So we call those double and triple bonds. So let's look at an example where we might need multiple bonds between atoms in order to gain that octet of electrons. So let's look at the diatomic molecule O2. So let's draw two oxygens, and each one has 6 valence electrons. We saw that earlier. Oxygen is in group 6 of the periodic table, which is why it has 6 valence electrons. Or at least that's how we remember it, right? So I do see one place where we can form a covalent bond. However, that's not enough for each oxygen, right? So if we look at the oxygen on the left, it only has 1, 2, 3, 4, 5, 6, 7 electrons. And that's going to be the same for the oxygen on the right. That one only has 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, so that means we need to adjust our figure slightly. So what we could do is you might have noticed that there are 2 unpaired electrons down here. So what if we move those over so that we can create a second bond? So then that's going to look like, let's see, I'll just draw the original Lewis diagrams for each oxygen. But let's move these 2 electrons on the bottom up. So now we're forming 2 bonds between the oxygens. So that is going to be our double bond. So now if we circle the oxygen on the left, there we go. Now we have 1, 2, 3, 4, 5, 6, 7, 8 electrons for that oxygen. And then the oxygen on the right has 1, 2, 3, 4, 5, 6, 7, 8 electrons as well. So now each oxygen is happy. So each oxygen has an octet. So let's clean up that drawing a little bit. So then we'll draw a double bond between the oxygens, and we can't forget those non-bonding pairs or lone pairs of electrons. So that is our Lewis diagram for oxygen. Now, there is another way that you can figure out more complex Lewis diagrams. So there's a lot of text on this slide, but I'll try to make it quick. So one way that you could figure out the Lewis diagram for a molecule is to first determine the total number of valence electrons for all of the atoms in the molecule. So for example, if we were trying to figure out the diagram for CH4, we know that carbon has 4 valence electrons, and then each hydrogen has 1 valence electron. So we would just multiply that by 4 for each hydrogen. So that would tell us that there's a total of 8 valence electrons for the molecule of CH4. And then the next thing we would do is draw a skeleton structure of the molecule. So very similar to what we were just doing, we would arrange the atoms around a central atom. So we would need to figure out what the central atom is. And then we would connect each atom to the central atom with a single bond. And that would look like, let's see, I'll do it down below. So we would just do something like this. And then remember, each bond is worth 2 electrons. So we would take our 8 total electrons that we had before and then subtract the 8 electrons we used to make bonds. So in this case, we wouldn't have any electrons left over. But in other scenarios, we might have some leftover electrons. If that's the case, we go to 3 and we distribute those remaining electrons as lone pairs on the outside atoms of the molecule. So we call those the terminal atoms. Now, of course, we don't want to do that to hydrogen because hydrogen only needs 2 electrons. It doesn't need 8. But we just want to make sure we're completing an octet for each atom. Now, let's say you do that and you still have leftover electrons. So then we'd go to 4 and we would place all remaining electrons on the central atom. And then the last thing we'd want to do is rearrange any electrons that could make multiple bonds with the central atom. So if your central atom still doesn't have an octet, we could move some electrons around to make sure that it does have an octet. So that might result in a double or triple bond. So let's practice this set of rules. Let's draw the Lewis diagram for CO2, which is carbon dioxide. So this is what we breathe out. We breathe in oxygen and we breathe out carbon dioxide. So again, the first thing we want to do is tabulate or add up all of the valence electrons for this molecule. So we have 1 carbon and 2 oxygens. So carbon has 4 valence electrons. And then how many valence electrons does oxygen have? 6, right? It's in group 6. So we're going to add 6 plus 6, so for each oxygen. So that gives us the total of 16 valence electrons in our molecule. So I'll just rewrite that down below. Now let's figure out which atom is in the center. So we know that carbon can make 4 bonds, and each oxygen can only make 2 bonds. So carbon is not only by itself in the molecular formula, but it can also make the most bonds. So carbon is in the center. So let's draw a skeletal structure first. So I'm going to put carbon in the middle, and then I'm going to draw bonds to each oxygen. So I'm putting my remaining atoms around the central atom. So each bond that I just drew is worth 2 valence electrons, so that's a total of 4. So what I'm going to do is take my total amount of valence electrons and subtract 4. So again, that's coming from these bonds here. So that tells me, let's see, that I have 12. valence electrons left. So usually molecules like to be symmetrical. So what I'll do is I'll divide that in half, and I'm going to give 6 electrons to the oxygen on the left and 6 electrons to the oxygen on the right. So I'm going to draw those as lone pairs or non-bonding pairs. Okay. So now let's double check and make sure that each atom is happy. So let's focus on the oxygen on the left. How many valence electrons does that oxygen have? Well, if we draw a circle around that oxygen and its electrons, we have 1, 2, 3, 4, 5, 6, 7, 8. So that oxygen is happy. And then the oxygen on the right is going to be very similar. So it has 1, 2, 3, 4, 5, 6, 7, 8. But let's check carbon. So I'm going to draw a circle around carbon and its electrons. So it has 1, 2, 3, 4. Okay, so carbon is not happy. It does not have an octet of electrons. But luckily, we can move electrons around. So if we go back a slide, remember in number 5, we said that we can rearrange the electrons of the outer atoms to make multiple bonds with the central atom in order to obtain octets wherever possible. Okay, so let's actually move, let's see, carbon still needs 4 more electrons. And remember, I mentioned that molecules like to be symmetrical if possible. So let's move one of these lone pairs from the oxygen on the left over, and we'll also do the same thing on the right. So we're going to make 2 double bonds around carbon. That way, carbon should have 8 electrons, and because those oxygens are still sharing those electrons, they'll also still have 8 valence electrons. So those oxygens aren't losing those electrons at all, they're just sharing them, right? Okay, so let's redraw this molecule. So we've got double bonds around carbon, and that'll still leave 2 pairs of electrons on each oxygen. Okay, so let's double check. Let's make sure everyone's happy. So let's check our oxygen on the left. So that has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Perfect. And we'll do the same for the other oxygen. That one has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Great. So those oxygens are happy. Let's do the same thing for carbon. So carbon has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons as well. So everybody is happy, and they all have 8 valence electrons. So that is our structure or Lewis diagram for carbon dioxide or CO2. So again, you can use these helpful rules if you're getting stuck and you're not sure how to draw the Lewis diagram. But you can also still use our previous methods too. You don't have to use these rules if you don't want to. It's just another way to do the same thing. All right, so let's do some practice problems. Let's draw the Lewis diagrams for the following molecules using those helpful rules. Or you can try to draw it on your own without those rules too. That's totally fine. So again, try to figure out which atom goes in the middle, and then surround that middle atom with the other atoms. and then try to distribute the electrons in a way that each atom has 8 total valence electrons, except for hydrogen, which only needs 2. So pause the video, try this on your own first, and then we'll go over it together. Okay, let's start with HCN. So we need to figure out which atom goes in the middle. Now we have one of each atom. We have one hydrogen, one carbon, one nitrogen. So the way I'm going to figure this out is which atom has or can make the most bonds. So hydrogen, we said before, can only make one bond. And we also said before that carbon can make 4 bonds. And then we saw previously nitrogen can make 3 bonds. So carbon can make the most bonds, so we're going to put that one in the middle. And then we'll surround carbon with hydrogen and nitrogen. Now let's tally up the total number of valence electrons. So hydrogen has 1 valence electron. Carbon has 4. How many valence electrons does nitrogen have? 5. So that gives us a total of 10 valence electrons. Okay, so I'm going to start by drawing covalent bonds between carbon and each atom. And that's going to use up 4 of my valence electrons. So now I have 6 valence electrons. Now I already know that hydrogen's happy. Hydrogen only needs 2 electrons, right? And those 2 electrons are in that covalent bond that we just drew. So I'm not going to put the 6 valence electrons on hydrogen. I'm going to put them on nitrogen, because remember, we want to put the valence electrons on the outer atoms first. So let's give nitrogen 3 lone pairs so that it has those 6 valence electrons that are left over. Okay, so let's double check. Let's see if each atom is happy. So we already said hydrogen's happy. It has 2 valence electrons. But then carbon and nitrogen need 8. So let's look at carbon. Carbon has, let's see, I'll use blue, has 1, 2, 3, 4 valence electrons. So carbon is not happy. But if we look at nitrogen, nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. So nitrogen is happy, but maybe we should move some of those electrons over and share them with carbon so that carbon's happy too. So carbon still needs 4 more electrons. So what I'm going to do is I'm going to move these 2 electrons over. So that'll give carbon 6 total electrons. We still need 2 more, so I'm going to move this one over as well. So we're actually going to create a triple bond between carbon and nitrogen. And then nitrogen will still have a pair of electrons left over. Okay, let's double check, make sure everyone's happy. So hydrogen has 2, we already said it's happy. And now carbon has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So carbon is finally happy. And then nitrogen should still be happy because even though we moved its electrons over to share with carbon, it is sharing them. So it still has some ownership over them, right? So nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So everybody's happy. Okay, so that's our Lewis diagram for HCN. Now let's go to CH2O. Now let's figure out which atom's going to go in the middle. So we know carbon can make 4 bonds, hydrogen can only make 1 bond, and oxygen, we saw previously, can only make 2 bonds. So carbon is still the winner. Carbon gets to go in the middle again. And then I'll just put the remaining atoms around carbon. Now let's tally up how many total valence electrons this molecule has. So again, carbon has 4 valence electrons. Each hydrogen has 1. And then oxygen, we said previously, has 6 valence electrons. So that gives us a total of 12 valence electrons. So now I'm going to make my covalent bonds between carbon and each atom. So that means we used up 2, 4, 6 valence electrons. So let's subtract 6 from our total. That leaves us with 6 leftover valence electrons. So where should we put those 6 extra electrons? Well, each hydrogen is happy, right? They each have 2 valence electrons in those covalent bonds. So we're not going to give hydrogen those extra electrons. But oxygen wants 8 electrons total. So let's give those 6 electrons to oxygen. And I'm going to draw those as non-bonding or lone pairs. Okay, so let's check and make sure everyone's happy. So we said already that each hydrogen's happy. They have 2 electrons each. Let's look at oxygen. So oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So oxygen's happy. But what about carbon? Let's look at carbon and all of its electrons. So carbon has 1, 2, 3, 4, 5, 6. Okay, so carbon still needs 2 more electrons. And remember, we can always move electrons from another atom. So let's do that with oxygen. So we'll move those down so that it's sharing them with carbon. So it looks like we're going to create a double bond between carbon and oxygen. And then we'll still have 2 non-bonding pairs left over on oxygen. Okay, so we already said hydrogen's happy. We already said oxygen's happy. Let's just double check that carbon is happy. So let's circle carbon, and it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Perfect. So that would be our Lewis diagram for CH2O. Okay. So hopefully that all made sense. Again, there's 2 different ways to figure out Lewis diagrams. So whichever way works best for you is fine, as long as you get the right answer each time. Okay, so I think we'll stop there for this video, and in the next video, we're going to look at how to name covalent compounds. So I will see you then.